Welcome back, everybody, to the series about making automated patch notes using Git history, the messages that go into your Git history when you do your commits, to automatically generate patch notes that can be consumed by all kinds of different target audiences. Zolmaniac, hello! I'm glad you're catching it live also. It'll probably be a fairly short one since I'm kind of starting a little late, but welcome. So on a few days ago, on part 2, I left off with having finished kind of a quick draft of the initial round of parsing of a Git message into an object that represents the format that we want to eventually turn these things into. To quickly recap, the goal of this thing is to allow you as a developer of a piece of software or a game or whatever to take the messages that you're already writing going into your Git commits and then convert those into patch notes that your players or users or internal staff or QA, etc. can read. It's based on the conventional commits/conventional changelog system, which is an open source system that lots of people have developed and made really cool tools for. It's trying to extend it to add some additional features, and also it's a little less, it has lower requirements. The conventional changelog system has very strict expectations about what goes into a commit, if you're allowed, how many changes you should be having in one commit, and so on, which just at least for us in our studio, don't reflect reality. And so I've already made a system like this that we use internally to generate all of our patch notes. So if you go to any of our games on our website, if you go to like bscotch.net/games and then go to any of those links that you see, you'll find patch note links. And if you see what's there, those are all automatically generated by the system we currently use. That one's old, it's a piece of crap, we need a new, better system. And so kind of for fun, I'm developing that because we don't strictly need it, but it would be nice to have. So that's what this is all about. We're doing this in Node and TypeScript, I guess specifically. And so a lot of what this series is about is how do you work with Node and TypeScript. And then otherwise it's all about basically Git messages and versioning and patch notes and all that good stuff. Love to know that you're here. Tell me what you're into. Tell me what you want to hear about. Ask questions as we go. And otherwise I'll just kind of keep on cruising. So we left it off last time in part 2. This is now part 3. With we did all of our preamble stuff. Got our environment all set up. We finished it by getting our linter added and getting prettier added so that we can catch errors before they become a problem, and so that we can have our code formatted automatically using a format that we don't have to choose and that we don't have to actually do. So if I forget a tab, who cares? If I forget a semicolon, who cares? It'll just get automatically added for me. So we did that, and then we wrapped up with adding a parser and a test for it. So here's the test, just to kind of recap. The test gives us a sample message. This is a template function that I have in a utility library. This is a publicly available library, so if you want it, you can install it using this. You would go npm install at bscotch/utility. So if you're going to do that, that would give you access to all of these things. It has full documentation on both GitHub and npm, whichever those things you're into. So one of those functions in there is this thing called undent. It takes this big, it'll take whatever you throw at it as a template string, which in JavaScript is a thing that is bracketed by backticks, and it removes the indents, not all of them. It removes the indents so that whatever the smallest indent is here, so basically this, right, gets removed from every single line, allowing you to make multi-line strings that are indented along with your code without having those indentations appear in the string itself. That's what that is. Grimlight, welcome, 3 a.m. Wow. You need to go to bed. I mean, hey, you do you, and I'm happy to have you here. I mean, I'd love to have you here, but if you're here instead of sleeping, I can't say that's a wise decision. But if you're here because you can't sleep, then this is as good a place to be as any. Giant Muskrat, welcome. All magic at this point. Yeah, I think it's one of the fun things about getting more and more deeply skilled at anything, right? Is that over time it becomes just no big deal, and you kind of forget that it's even cool. But all the way up until that point, everything was very, very hard. And honestly, most of the stuff for me with TypeScript in particular, but even Node, which I've been using for years now, a lot of what really advanced my knowledge was very recent because I refactored our entire web infrastructure, which was in vanilla Node, I guess, into TypeScript. And doing that forced me to confront a whole bunch of things that I thought were true that weren't, and so I learned a lot as a consequence, and that's helped with the fluency aspect of things. So the beauty of robots, and I love making robots, it's just my favorite thing in the world, it always looks like magic from the outside. In the end, it's just me and my dumb code, you know? Nothing special. If you have questions, if something looks like magic, and you can't quite figure out how to formulate a question, you want to ask me in the chat, just give it your best shot. I'll see if I can figure out kind of what you're getting at and try to explain. So this thing, undent, it just does this kind of cool magic. And that allows me to just have nicer looking code when I'm testing things like strings. So last time we made this sample message to give an example of what kind of messages, the kind of stuff that is going to end up in our Git history that we want to convert into patchnotes, so that we could then write a parser that converts that into a collection of objects that are well defined that we can then use to construct a data sort of structure, construct a data structure that we can use to do all kinds of stuff. In particular, create patch notes in various formats. So in here you can see I've taken the conventional changelog format, which looks like this, where you have some sort of a type of change. So it's like a feature or a fix or whatever, and a description of that change. Sort of classic Git message contents includes your original line. So this is often if you're doing so you can see down in the what do you call this? The terminal down here. I'll pull this up while we're talking about it. So if you were to do a git commit -m for dash message, and then type in the string here, blah 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 blah, that thing is kind of considered as the git message. It's the title. It's the single line. If you're doing a git log with a single line output, then this is the thing that's going to appear. So this is basically the first line of your commit message. If you do a git commit without the -m, the -m allows you to just write an inline message in the command line. If you just do a git commit, it'll open up whatever editor you set in Git, which you can change, by the way. So if you didn't know that, there is a Git setting. You can just Google it. I don't remember what it is offhand. That would let you choose anything you want to be your commit message editor. Could be VS Code. Could be Notepad. Could be Notepad++. Could be, I don't know, just any Paint, I guess. That probably wouldn't work out the way you want, but you could probably open it up in Paint. Paint.net, is it now called? No. 3D Paint, Paint 3D, whatever Windows has these days. I wouldn't advise doing that, but you probably could. So that message can then have multiple lines in it. If we're following kind of the standard way of writing text in command line and in code and so on, white space doesn't matter that much. And so if I were to have a second line here, where here's my second line, that's actually treated as part of the first line. That first new line doesn't actually matter. It's always the consecutive new lines, making a blank line, that separate what we consider one line from another line. So then a classic sort of I guess default interpretation of a Git message then is we have our title line, and then we have our body, and then we have an optional footer, which are just things separated by pairs of new lines. Johnny Muskrat, can it be GMS? It absolutely could be GameMaker Studio. Again, could be. That's assuming that GameMaker Studio knows what to do when you try to open a text file. I don't know. As long as you can open it in something, so like the thing can take a hook where the operating system says, hey, open this text, right? And you can save it in there, and it'll save back to the same place, then you can edit it in there. GMS is not the best text editor, but you could potentially use it for that. So this is sort of the anatomy of a Git message and people's interpretation of it. A Git message is actually just a piece of text. It's just a piece of text. You can interpret it however the hell you want to. It doesn't really matter. It's arbitrary. You get to choose. But the tools that are out there interpret that first line as a title, then the body, and then an optional footer, and so on. So what we want to allow here is for us to be able to use things like git squash, or to, if we aren't practicing really, really good Git practices and we make 2 changes instead of just 1, and we can't find a way to make that into 2 commits, then who cares? That's fine. We'll just put all those messages into 1 commit, all those changes into 1 commit. So that's what this is modeling here, is here's one change, which I'm documenting using that conventional changelog syntax. So here's the type, here's the title, here's the body. Here's another one. This one's a chore type. These are typically excluded from the output patch notes. Here's 2 back-to-back ones that are not separated by 2 new lines, which could be considered invalid, but I would prefer the system to be really flexible so that it can just see that and then do the right thing. Here's another one, and now we introduce the idea of a stream. So this is a new feature that I'm adding on to the concepts that are in conventional changelog, which would allow you to whitelist or blacklist some streams so that you could then choose which messages actually show up in some set of patch notes. So this is the sort of secret sauce to allow you to generate one public facing, so here's pub for public in this case, one public facing set of patch notes, and then internal patch notes or patch notes for QA or whatever. And then we'll keep going, and then part of what I want to do to extend my previous system is make this a little more generic so that we can have this idea of tags. So it's not just like a stream that has a name, but that you could just tag your messages, tag your commits, or more specifically, I guess, the messages within a commit, since you can have more than one message for one commit, allow you to tag them so that you can build your distinct patch notes that way. So that was the test case, and then we made a getMessage class with a parser static method on it, and that thing parses this and gave us basically what we wanted, so we can rerun that just to make sure that that's true. As a additional reminder, where we're at, here we go. We also added these scripts in here, so we can run these scripts with npm run and then the name of the script. And so now we have this test script that does build, so that way it guarantees that we've compiled all of our TypeScript into JavaScript, and then it uses Mocha, which is the test framework that we're using, to run those tests. npm run test. So all of those are, so you can see it's our test file right here that we were just looking at, and then we have the output build folder, which got deleted, but will show up again in a second here. There it is. And this has all the same stuff we've been doing that wasn't TypeScript, but now in JavaScript, with some other cool files that I think I talked about in one of the 2 prior parts. So now if we look down here, you can see what the output of the test was, which is all this stuff. So at the very end of the last part, we walked through all of this, and so you can see, based on what I said was supposed to be happening here, with all these different entries in the same get message, you can now see we have all these different objects that came out, where they have their content that's all been parsed out. It's got its type, and so we got type. Scope would be this part right here inside of parens. And again, this is inheriting the ideas from the conventional changelog system. So that's all in there. We know where this thing is in the original string and so on and so forth. So we got all that done. We ran this test, and you might note that nothing is actually being tested here. There's no assertions. There's no saying what is expected to have happened here. At the moment, we're just kind of exploring the output to make sure that this is working the way that we want. We'll wrap this thing up with the full tests afterwards, and so something we can do here to make sure we don't forget that we actually haven't done a real test here is just to force it to error out. So there we can use, actually I have to install it. So we're going to install a thing called chai. Speaking of, tea and stuff, which we were earlier for anybody who came in later. npm, oops, missed something, npm I for install. Chai is the package we're installing, minus capital D for install it as a developer dependency. So here is npm chai. So chai is actually just an assertion library, but it's a really well and cleverly constructed one that allows you to write assertions. An assertion is just a claim that if it's false, there's an error. So let's write assertions in a way that's really Englishy, that's really pleasant to write. And it has various modes, so you can basically chain calls together in a way that kind of looks almost like a sentence, and then have it tell you whether something is what you want it to be or not. And because it throws an error, the way that test frameworks typically work is unless an error is thrown, it assumes that your tests pass. And so the way that you show that something is wrong is by using assertions. So you assert something. If that thing is falsy, or false depending on the system, then it'll throw an error, and then the test framework catches that error and says, hey, this test failed. It'll typically continue moving on and testing other things even though you threw an error, so that I can now collect all of the errors instead of just the one that was first thrown. So I guess there's a whole bunch of stuff here. I don't want to get really deep into Chai unless someone's curious. But they have a pretty nice website that explains how things work. They've got an API. They have multiple APIs, actually. So there's the behavior-driven... Wait, is that right? Behavior? No. Is that right? I think it's behavior-driven development versus test-driven development, which is kind of two different syntaxes for doing the same thing. It's still just writing assertions. I typically use the expect syntax. So here's the versions. Here's the should. So you can say things like, this thing should be something. So I don't like this one because this requires mutating all of the underlying JavaScript sort of foundational elements so that these weird functions exist on them now, which is cool. And it's not likely that you're going to run into conflicts with that, but that makes me nervous, so I don't use that method. And there's assert and expect. So assert is just like a classic assertion library, and it works great, but it's less fun. I like the expect version of this thing because it's the kind of the one in between where it's nice and Englishy, but it doesn't actually mutate your underlying data, which seems like a nice little bonus there. So we will install that, or did install that, and then we can just kind of just bring it in here. So you don't have to use an assertion library. We could write our own assertion functions if we wanted to. We could do sort of a function, assert. Also, Node has some built-ins that we could use too. Basically, to make some claim. That claim could be of any type. Basically, I'm going to assert for truthiness. So as long as the claim is truthy, which in JavaScript, most values are truthy, and then there are a handful of defined. There's a handful of defined values that are falsy. So basically, as long as it's not one of those, then this claim would become true. Then we can have an optional message. So that question mark is optional, where we could say if that assertion is false, that's the message that we provide, and then we can just do something like if claim. Actually, no, we'll do this if not claim. Then we'll throw an error, and we'll provide that message. Or if there wasn't one provided, then we instead will fall back onto something else like something went wrong. There you go. Simple. So then you can do this really nice TypeScript trick here, where so if I have a function in TypeScript and after the function sort of definition part, I guess, I can tell it what type I'm expecting this thing to return. So that gives you a whole bunch of benefits. But in particular, if you want to do something weird, like say asserts claim. So this is a keyword that's built into TypeScript that can be used for return values of functions or return types of functions. And I can actually pass it the original value in here that I was passing to this. And so what this thing does is says that it says that this function is asserting that this is truthy. Therefore, if it's not, it's going to throw an error. So TypeScript now knows all of this. And so if at some point I have a line in my code where I say assert something, then on the subsequent line, TypeScript knows that that thing cannot be falsy. So I can use that to my advantage to make my type system work a lot better. Bryce asks, is 0 falsy? Yes, 0 is falsy, and -0 is also falsy. If you didn't know there was a -0, now you do. Most of the falsy things are things you'd expect to be falsy. There are some weird cases because there's two ways to think about falsiness, where it's like false equals some value, right? So in JavaScript, a double equal means basically approximately equal, sort of, versus a triple equal, which means exactly equal, so those are evaluated differently. Falsy you can think of as meaning that a thing is approximately false. So like 0 is sort of false, an empty string is sort of false, and so on. But that's not exactly how it's done. And so there are some cases where this statement will evaluate to true, so you think the thing is falsy. But if you, or sorry, it'll evaluate to false, so you think the thing is truthy. But then if you put this same value in an if, like if that thing, whatever, in that context it actually evaluates as falsy instead. So it's a little weird. It requires kind of just learning things and then just being really careful. A lot of people say that you should always use triple equal to say like, this thing is definitely exactly equal to this thing, unless you have a good reason to use an approximately equal. I do it the other way around, which can get me into trouble, but I like to use my falsy values in a kind of a flexible way, which can lead to errors. But TypeScript helps you avoid this, so I don't know. I think it's a net win. Giant Muskrat is -0, something that occurs on purpose or by accident. It's something that I think probably mostly occurs by accident, but it actually can be a useful feature, because with the binary representation of data, typically some bit in the collection of bits that make up that number is reserved as this is the thing that makes it positive or negative, right? That's not actually how it works really, but conceptually that's how it works. So basically for any given data type that has both negative and positive values, it's basically symmetrical around 0. You have just as many positive and negative values, right? So if you think of like 8 bits, that's 2 to the 8 possible values, that's 256 values, right? So in principle, that's 128 values to the right and to the left, right? Except that you need 0 in there, right? Actually, you have an odd number of values because 0 is in the middle, right? And so you can't have an even number of possible values when it comes to numbers when you represent them with binary. And so what happens is that you end up basically with 2 versions of 0, where one of them we can call -0, one we can call +0. You can represent that in different ways, and so depending on how you represent it, that ends up differently. But the end result is that for lots of languages, actually I shouldn't say lots, at least for JavaScript, and I know some others, -0 is an actual number because it's the bit representation underneath for 0 plus whatever it is that makes a thing negative. If people are going to use this at all, what they'll use it for is to store some piece of information, right? So a really good example is sometimes you have more than one sort of falsy state where maybe a thing is actually 0 or it could not exist, right? So maybe you have those two options. You could represent the thing as 0 with +0 and the thing doesn't exist with -0. And now for all cases, you're still using numbers. So if you have a situation where you can't have sparse data where the field just doesn't exist if it doesn't exist, or where you can't have data represented by either a number or a Boolean false or something else, if it has to be a number, but you need 2 ways to represent something that conceptually is similar to 0, you can use +0 for one and -0 for the other one. So that's the only case I know of that you actually use that. There's probably some other use cases. I don't know. It's weird. I don't know how stable it is either. I don't really trust numbers that much because of floating point math, and because especially on the web, you're sending numbers from the browser to the server and back, and then depending on what the server is using, it might interpret the number slightly differently, and so on. And so I would be very nervous using a -0 for anything. Cool. So that's the idea here. I'm just going to keep this because assertions are nice. Actually, we'll put this in the library here. New file. We'll put this into errors.ts. Put this in our library. Now we have an assertion function. We can keep on adding cool stuff to it if we want to. Because why not? And now we're going to export this so it becomes available to the rest of our code. And I should also, what is this squiggly line for? Doesn't like any. Too bad. I want to be able to do explicit any's. You can't stop me. So ESLint is going to come with some default set of rules. You can opt in or out of whichever ones you want. How protected you want to be, what kind of coding style you want, if you're working with a group of people, how comfortable everybody is with all the different things you could allow yourself to do, and so on. So here's my ESLint RC. This is the thing that controls my lint rules. So I'm going to turn this one off. So the reason you might have a no explicit any set to, I guess, on or true, whatever, you might have this so that, because any is typically thought of in the TypeScript community as a failure in typing. Like you gave up, so you just said this is anything, right? And that's often true. Especially when you're new to TypeScript, you'll often find yourself just being at a loss and not knowing what to do, and so you just say, oh, screw it, this is just an any now. That can get you into a bad spot, but doesn't guarantee that it is, and often that is the kind of thing that you want to do. So a good example is this very function right here, where I want to make a claim, but that's just any falsy or any truthy or falsy values, literally anything. Anything could be in here, and I'm just going to evaluate its truthiness. And so I should be able to do that. And I have two options here. One is I can say, usually I consider that an error, and therefore I keep that rule, and wherever I want to bypass the rule, I basically do an inline comment like this that tells ESLint to just stop paying attention right there. That's not a bad practice. I just like being able to say something as any, and I don't want ESLint to tell me what to do with that thing specifically. I often want to tell me what to do, but that's not one of them. So now I have this insertion. You can also make custom error objects in JavaScript, and so you can use these to now append different kinds of data onto your custom error class, and you can further use that to do other kinds of cool weird stuff. So in some of my other projects, I have custom errors, custom error types that allow me to then evaluate things when I'm logging. So I can say, if this error is an instance of this class, then log it this way versus some other way. And you can also have functionality added to it, so that when an error of a certain class is thrown, maybe it itself does some logging, and that just happens actually in the error instance itself. Or what else can you do with custom errors? The other big thing is you can also change how, so if I just throw an error, let me just do it over here in this, we're just talking about random stuff right now, but that's fine, that's why we're here. So if I were to just, actually let's do it inside of, where's my tests? Lost my test, there we go. So let's run a test in here. So I'm going to assert something. Oops, does this import my asserts? Yes, perfect. So in here, I'm going to assert that, let's assert something obviously false. Obviously falsy. False is obviously falsy, right? Hopefully. And I'm not going to put a message here, so I'm just going to make an assertion. So this right now, unless there was an error thrown here, then this test would pass. Since I'm asserting something falsy here, then that's going to cause this whole thing to fail, and now you can see what that's going to look like. So that run test is going to rebuild everything from TypeScript into JavaScript, and then run these tests. It's going to make this assertion, and then it's going to throw an error. And then we'll see how this gets logged to your console. This is now npm running something through Node, which is your script in turn. So when you're running things that way, you'll often see this kind of final thing, but we're going to ignore that because we don't care about that part. What you'll see here now is we ran our tests. So here's the build script part, and then here's the compile part, and then kind of invisibly the test happened. You can see the message. So the message is right there. That's the thing I might describe. And you can see then the other message that's inside of this it right here. This thing right there. So this is the specific test. And then you can see that I got this error. Something went wrong. So this is how Mocha logs an error. It basically catches it, and then it drops the stack trace down here as well as the message, and it does some nice formatting so that the message shows up in red and blah blah blah. Now you'll notice here that these things show up basically as clickable links, and so if I shift click, control click, when you hover you can see that right there. So when I control click, that takes me right to the thing that threw the error, which in this case was the error, but I can go back down the stack trace a bit, and hey, the error was right here. Which is true, because I asserted something that was false, so that's what the source of the error. Now you'll notice that this thing is in the JavaScript, right? See that? So now I'm in the compiled JavaScript because that's the code that was run. That means that's where the error gets thrown. That means that's where my stack trace puts me. So you can do some tricks to make it so that this stack trace gets rewritten to replace all of the errors, or sorry, all of the file paths with your source file paths. And even better, it remaps the line numbers and the column numbers and everything back onto your source code. So this is the idea of source maps, which we can see in here. So if we look at our compiled code, we see that's our type map. Here we go. So here's a source map. Cryptic, weird nonsense, right? But you can see we got a source. This is for this now errors thing. You can see the source is, here's the relative path to it. There's the TS file, which is the source TypeScript file. And then you can see all this weird mapping stuff. This is basically just like mapping lines and columns onto each other. TypeScript does a bad job of this if you're not using ESM. If you're using ESM, your compiled code looks really close to your source code, and so then it's fine. If you're not, then a whole bunch of weird stuff has to happen if you're using CommonJS as your module import syntax. So if you're doing that, then a whole bunch of weird stuff has to happen that causes new things to appear and things that you had written in a certain way to not exist at all anymore. And so now all of a sudden, a whole bunch of the names of your tokens, like your variables and stuff, just have changed. So if this was being handled properly by TypeScript, that would be populated here, where it would say, oh, here's the list of the names, and then the mappings would include mapping names onto each other. So other things like Babel and presumably some other things that can compile TypeScript to plain JavaScript actually do populate these. So one of the big reasons I switched on my big project from using TypeScript as my compiler to using Babel as my compiler, just using TypeScript for types, was because I couldn't get good enough debugging, because mapping these on was a big problem. So if you're writing your source code in ESM and ECMAScript modules, in module syntax, there's 100 ways to say it, then your compiled code is going to be in CommonJS unless you specify for your node project that it's actually using modules. And then in that case, that compiled code is going to be different enough from your source that your debugging process gets really rough. It sucks. That was one of the big reasons to change. And then finally, there's still that last point that even if you do use it as ESM, there still could be enough changes that the absence of this names mapping here, that TSC is missing, can still be a problem, which Babel fixes and some other projects also do. But anyway, what were we talking about? Okay, yeah, so it's throwing an error, and so, like I was saying, this thing is giving us these errors in their non-source location. So that's actually something we should probably fix kind of out of the gate. Fortunately, there's a very easy way to do it. Node source maps support, that's what it is, source map support. So you can use this project, you can see, very popular. Kind of makes you think maybe this should be just built into Node or something. So this thing has a few ways to use it. You can see one here is that we can call it when we're calling node. We can pass, so -r means register. You can also do -- register. And that allows you to supply some JavaScript module, could be anything, that will basically run in the same process before the rest of your code. So you can use that to modify sort of the global behavior of your project. This is also how you can do things like, so you saw when we're running Mocha, we just run it with the command Mocha, but you could also run it with node -r, and then there's a Mocha script we can refer to, and it basically runs node, loads all the Mocha stuff, and then that in turn loads all of your scripts, and it kind of works out the same way. So we can use it via the CLI, or we can do this magical thing where we can just do an import statement anywhere in our code, as long as it gets loaded early, that will just make it so that now all of our errors have fixed source maps. Oh, there's a bug on my screen. I know you can't see it, but I can see it. Anyway, so we can install this thing, and then have our source map support. What if we'll actually make it do any programming today? Probably not. That's fine. I'm just here for a good time. We're gonna do this with a regular install because we want this to ship with the project, so that when the project fails, the project will succeed. when our user does something wrong and it throws an error, then even though they're using it on their machine, it's the compiled thing that they got delivered to them via npm js.com, because they ran their own npm install, they installed this project, etc. If we want them to also get accurate errors so that we can find it. So we're going to install it to our dependencies instead of dev dependencies, which means we're not putting in that dash capital D, which is synonymous with dash dash all lowercase. Camel case. No, Pascal case, camel case. Which one starts with a lowercase? Whichever. One starts with lowercase. Dev dependencies. Okay, so that's installed. And again, we can do it in either of those two ways, but since we want to ship it so that this will just work, then we're going to do it by loading it. One note of caution, if you're going to do something like that. If we load it that way, then if somebody loads our code as a dependency, so if they're not, this is going to be a CLI tool, but it'll have code that could be loaded so that somebody could make their own pipeline that incorporates the functionality. That functionality will also load this script. So if we are in effect opting all of our downstream users into using this thing, and there's a concern there because when we do that, the way that script actually works is it rewrites the behavior of the error object and how it does a stack trace, which we could actually walk through. I can show how that works. And because it rewrites that, then if somebody else also wants to rewrite it, so now if the downstream consumer of this API that we're creating wants to do their own rewrite of it, now all of a sudden they're in conflict, which is not good. So it is a little dangerous to do that. I'm going to start that way for now. Actually, no, okay, so yeah, because the question is, do we care if a downstream user gets messages that bring them to the compiled code? And actually the answer is probably no, because they don't have the source code anyway. They only have the compiled code. Right. Okay, yeah. No, that tracks. That tracks. So I'll show you what that would look like. Oh, this is the JavaScript. It's got the JavaScript. Typescript. So what that would look like if we were going to do it that way, which again, it's neat that it works, but we shouldn't do it. So this is called source map support / register. So we can just import this thing right here, and that's done. So this is a good way of doing imports if you want to have side effects happen. Is you can import a module, all of its code will run, even though we're not importing anything specifically out of it. This will still allow you to run code from something else. So this is how you do it, and then you're done now. You already did it. It may be the case that we have to slap a .js in here since we're using ESM to make this actually work. But we would get an error if we needed to, and we're not doing this anyway, so that's fine. It is worth noting that in exactly the same way this works, there are other weird things you can do that if you import early can mutate downstream behavior of your code. And there's another really popular one that's probably worth mentioning called ESM. Okay, I'm pretty sure it's just called ESM. ESM. ECMAScript modules. This thing. It's woefully out of date, so that's a huge bummer. Still extremely popular. I've used it a fair bit, but I found that with some of the really modern stuff, it doesn't work, which is a bummer. Some of the more modern JavaScript features, because it just hasn't been updated for a long time. But it's still probably working, I think, in most cases. It's the same kind of a deal, where this allows really nice interoperability between CommonJS and ESM without you having to do all the work of trying to figure out how the hell to make it all work. So that's why it's so popular. It's very helpful, and it can work the same way. You can either call it via the CLI, or do the same thing, node, and then do a -r for register, and then that module, and that basically magically makes all of your module confusion just work. Or you can just import it, which here they're showing with CommonJS, but that's fine. Yeah, same idea. But yeah, so you can basically just require it, and it'll just cause all those changes to happen. In essence, it's rewriting all of your requires and imports. So that's neat. That's pretty dope. See a new hello, Eagles _. Welcome to the chat. or I guess the stream, and also the chat. As I said before, if anybody has any questions about anything, just here hanging out. So we'll do a little bit of coding, but we're just talking about any kind of cool, weird JavaScript and TypeScript stuff we want. All right, so we got the source map support installed, and now we can run it. So we're doing this thing through let's see, actually, hold on here. So if we do this through Mocha, it behaves a little weird if I remember correctly. Mocha source map support. Oops. Support. Mocha require. Oh, you can still just do it that way. Yeah. Wait, can we do it? Or is this somebody saying we can't? Mocha. Yeah, we can just do it. Rad. So let's try this thing out so you can see it in action. Package.json. So we're going to rewrite our script. This is now, all these things again run with npm run and then the script name. And this is just some arbitrary command line stuff. It can be whatever you want, doesn't matter. So now we're going to update our test script, which is currently running. It's doing a build. We want to keep doing that. And then it's after that, it's running Mocha. And so now here we're going to do a -r, which again could also be a -- register for source map support. Get rid of those quotes. Why did you autocomplete and stick quotes around there? It's not what I want you to do. /register. So this is because you can import this module, but this is the registration function within that module. So that's what we need to use if we're doing a register. We could go look at it if we wanted to and see what's in there. Why not, actually? Let's just go take a quick gander. So all these things up in node modules. That's where all of your npm installs go. So we can look at source map support. Look at all these things. People make fun of Node so much because every time you do an install, you have 5,000 files appear. And they're not wrong. They are not wrong. But hey, you didn't have to write those files, you know? You just get to use them. Okay, so here we go. So here's source map support. You can see they've got a browser component, so that's kind of cool. And then we've got, so here you can see now in the package.json. So this is weird because this is what a package.json looks like when you take a Node project that has a package.json and you, what's the word I'm looking for? Publish it. When you publish it to npm, it creates a new variant of that package.json that has a bunch of other kind of like stuff injected into it, which is all this weird underscore stuff. But you'll see in here there's a path called main. So the way that an npm package works is that if there's a field called main that points relatively with a relative path to a JavaScript file, then when you do an import in your own code, basically what happens is Node says, oh, I see you're importing, in this case, source code or source map support. And so it looks for, in your Node modules, a directory called source map support. It then looks for a package.json in there, finds it, opens up, looks for the main entry, sees what the path is, and then goes and loads that JavaScript. So it's actually simple. It seems like magic, but it's actually just this little simple thing. So that's what's being loaded. Now you also see in here what we're doing is we're importing this thing /register, which is this. And so all this is doing, so this is common JS style. So this is doing a require // means local directory, and the node style stuff falls back onto index.js, which is, or sorry, I guess in this case it would be onto main. So main is again source map support. So we just right back here again. So it basically loaded this thing and then ran something called install, whatever that is. Install. There's a lot of code in here. Okay, there's a lot of code in here, so maybe we don't want to dig into this that much. Anyway, it's in there somewhere. We don't need to get into it. That's fine. So this will register whatever that was, and it'll run that install command. And again, that's happening now basically in the same node process before the rest of your code loads. So now what we should see here is, let's get back up here, close that, there we go, so we can see stuff. So we'll just go rerun that test, and we're still throwing that error, but this time when we get that error thrown, what we should see, if this worked, is that when we control click that path, it's going to take us to the source code instead of to the compile code. And here you can actually see it. .ts instead of JS. Now I click there, back in my source code. So this is a really nice improvement to the developer experience that if you don't do this, going from having an error you're trying to debug back to your code to debug it is really, really frustrating because you just keep on ending up back in your JavaScript instead of your TypeScript. So that's what that is, and just because I said I would mention it, then I'm going to go ahead and do it. If I wanted to make a custom error, then I could just do that. So I could just say class, and here we'll call it patchnotes error. And this thing is going to extend the built-in global error class. And I can add a constructor in here, which would then take a message string. Let's make this optional. That way we can throw errors without providing messages, because that's nice, I guess. And then we can call super. So what super does is it basically takes whatever the parent class is and calls its constructor. And in fact, in JavaScript, you have to call super. Got to do it. And it also has to be the first thing that you do once you're inside of a constructor. So I'm going to call super with this message, and because that's optional and super actually requires something, I think, for sure, then I'm going to have this fall back to, basically what I did previously. Just take this guy. And then here, I can now throw a new patchnotes error, and now I got my dope custom error. So name is something that lives on the error class, and so I can just change its name to be called patchnotes error. Now if we run that same thing, you'll see it again. And again, the benefit of this, there's a bunch of them, but when you use, there's a operator called instance of in JavaScript. So I could say like new, let's call this thing, new patchnotes error, instance of new, instance of error, right? So this instance of operator basically takes the thing on the left, which should be an instance of some class, and a class on the right, and just returns true or false if it's an instance. But it works through inheritance. So this thing is going to evaluate to true because patchnotes error extends the error class, which means it is technically an instance of error. But then I could use this more specifically to ask if it's one of these, right? And then if the answer is yes, then I could do other stuff. And for TypeScript, because this idea is called a type guard, where you basically say, I'm going to check if this thing is of this type, or if it's an instance of this class or whatever, and then a subsequent code, then TypeScript now knows that that's what the thing is, and so it can give you the correct autocompletes for stuff, which is very handy. So we do something like this, and then here we throw this error down here, and now we can look at it. So, oh look, there's the name right there. It's now called a patchnotes error instead of just an error. And we see the message just like we normally do, and you can also see that my stack trace still worked as intended, and all that kind of stuff. So that's great. I basically haven't done anything here except to make it a new error class that has its own name that I can check instance of if I want to. That way I can tell the difference between errors that I've thrown versus errors that Node has thrown from internals or something. And I can have a default message, so I can just throw an error and not even worry about it. Which isn't that helpful because then I don't necessarily know why. But, you get pointed right back to where it was with the stack trace. And so who needs messages, So we do that, and then there's a final piece of this puzzle, which I always forget, which is called Error.captureStackTrace. So this is the error class, and I'm calling a static method on it. So I'm going to have a target object, which is this, which refers to self. It's like self in Python, or what other languages have this? Probably every language has this same concept. Constructor options, which is just my constructor, which is this constructor. Yeah. And so you do this thing so that the capture stack trace basically doesn't include the stuff that's happening inside your constructor here, because you don't want that. If you don't do it, it's not the end of the world, but it's preferable to have it there. So this is your sort of way that you make your own error class. That works the same as a normal error class, except you can now add features to it if you want to. You can add more arguments, you can add more defaults, you can just do all kinds of stuff. And now we got one. And then the other thing, so this is now for basically setting this stack trace capture behavior. But we can also on the global on the error class. So remember that TypeScript or JavaScript is a dynamic language, so we can just edit everything on the fly, right? you can change anything at any moment as long as it's not a read-only property of some sort. So error, you see we have, so some of these are just are things that error inherits from its base class, sort of conceptually. So JavaScript isn't technically an object-oriented programming language, but it's close enough conceptually. So it inherits some of these things already. So like apply and arguments bind, all these things are inherited from basically just a function, which is basically what an error's parent is. So the one that is new is basically these two. So stack trace limit. So you can see down here we got like, what is this, 3 things in the stack trace. There's like nothing in here, right? Although part of this is because the code wasn't doing anything, so that might be the main reason. But if we wanted to, we could set that to be stack trace limit. We could say, oh, I want this to be 20 if you wanted just to get a huge stack trace. The advice is always to have that be as small as you can get away with because it's relatively costly to store these things. So that's the thing you can do, and you can also do the more interesting one, which is error.prepare stack trace. So this thing is a function that, so you can see I'm hovering over here so I can see what's in here. So here's my prepare stack trace function. It takes an error as its input, and then stack traces, and then it can return anything at all. So the default prepare stack trace is the thing that basically takes the stack trace, and then creates this exact string that gets dumped into your console that you see. That's what this thing is by default. But you can just change this to whatever you want. So you can just be like, oh, this thing now is actually a function that all it does is just returns a string that I'm going to call whoops, right? And now if I run the same code all over again, then I have basically nuked my ability to actually read a stack trace. This is why I was warning against the idea earlier of so here we go, right? So that's what we get now, right? So we still have the message up here because it looks like that must be somehow separately written from the stack trace. But our stack trace is now just the text whoops, which is not particularly useful, right? So this is why I was warning against the idea of using one of those functions, even though that would be really useful to do it, where you register it very early in your code to make it so that you change the behavior of your stack trace or something, because when you do this, it's global. You're doing it for every piece of code you import. If somebody imports your code, everybody's code now uses this thing. So you want to mutate that with caution. When I do it, it's usually for stuff that I'm using to inherit other people's stuff, but I don't intend to distribute in any way. And that'll typically be to do things like mutate or to rewrite these paths and things to like make them relative, or in the case of a really weird development setup like I have for my web servers, my web server actually runs in a Docker container, but my code is managed locally. And so the paths that come out of an error are relative to the inside of my Docker container. That actually is running the code. But I want to actually instead have the path relative to my development environment outside of the container. And so that's the kind of scenario where I have my own captureStackTrace function that basically takes what was inside of that Docker container, takes the stuff that was being run there, and identifies all the paths and rewrites them so that they are relative to where I'm actually coding from. Again, allowing me to then just to control click on the stuff and go right to the source, even though technically it's running inside a container instead. Okay, cool. So it's already been in it for an hour and we haven't touched any of the code for this thing at all. But we talked about some cool stuff. Yeah, it's kind of neat, right? The weird behaviors of JavaScript. Okay, so we're gonna undo that and we'll keep this because this is all useful to have. And it's also, once you start doing assertions, you can also have some like built-in assertions, or I guess convenience assertions for things that you do frequently, like assert is number or assert is valid date or whatever. So especially things that are kind of hard to check. All right, so if we go back here, then we're going to continue asserting false because we want this to fail because we're not actually doing any tests yet. That way we don't forget to add tests later, just think that things are working when in fact we actually haven't tested them. So this is not test-driven development, by the way, because, well, sure, I have a test case and I have a sample and I'm running the code so that I can test it. I'm not actually making any claims about the results. So this is not a legitimate test-driven development. But you know, it's something like that, something approximating it. All right, I got a bunch of crap open here. Let's close some stuff. Don't need this, don't need that, don't need this, don't need that, don't need any source code. Do not care about source code. Or sorry, build code. We only care about source code. All right, so where we left off last time, it was with this get message class. It basically takes a message. So this is the get message. So the actual full piece of text that's in the get message. So if I were to do a get log right now, get log, get space log. Oh, come on. Come on, you can do it. All right. So if I do a get log, then you can see, oh, here's all my commits, right? So this would be a message, for example. So that's what this thing is going to take. It's going to take a message, and there's a static parser in here. I made it static so that we could access it outside of a class instance if we wanted to. And as I mentioned last time, there's going to be a lot of refactoring as we figure out kind of how this thing is going to work. If I were a good architectural designer when it comes to code, then I would already know exactly how this is going to look. I would know what my classes are, what all their static versus private versus whatever methods are. I would know all of that stuff, and then I would just start doing it. I'm not though. I'm not an architecturalist. I just kind of get a rough idea of what I need to do, and I get started and I refactor as I go. I'm just not that good at planning. So here we are. All right, so now we've got this message. It's going to come in. We've got a parser. We've tested. I guess we have seen what the parser outputs. But what we were left with then is this parse log thing, right? So this parse log thing looks like this, and we saw that in the output when we were in the test, where it's got the type, which is now one of those like feature fix, etc. It's got the position inside the original get message. It's got the content, which is the full string, including the title line and all of that. And then a tag if there was one, but that's now that upstream tag, the one that's inside the parens, because now with the new system we're also adding downstream tags, which means actually that we should change this thing to be tags. And then I mentioned this last time too, that here I'm claiming this thing as a parse log by first telling it that it's unknown. I'm saying I don't know what this is. Then therefore there's JavaScript, and I say, okay, it's an unknown, therefore nobody gets to have any opinions, but I can now decide it's whatever I want it to be. So in here I claim this thing as a parse log, which is just not true. That's just not what this thing is. And that's a dangerous thing to do because it's just wrong. It's missing some of these components. On that note, probably what I should do is just stop doing that because it's too dangerous and we're gonna get into trouble. So let's type this with what it actually is. So these are its parts, which we can see just right up here. These are these named capture groups inside this regex. So we're going to make these optional, because the only thing that is not optional is the type, which is that first part. So now that's what this thing actually is. And then we can make a new thing, which we will call message, or we'll call this a log. And this thing is going to be of type, that guy, parse log. Parse log, and this is now going to be equal to, we're going to spread the message parts. So spread operator in JavaScript, one of the coolest things that exists. It basically takes all the key value pairs inside of this object, inside of this thing, and unpacks them, right? So basically unpacks them into this one. So it's a way of basically making now a flat structure without like having to grab each value independently or whatever. So if I just did nothing else, just left it right here, then in effect log is now a clone of message parts. This is also why Typescript is upset, is because I guess it's upset for two reasons. One is I don't use it, but the red squiggly part under the yellow squiggly part is because it's really upset that the types don't match. It's like, hey, you're missing all this other stuff. Where's your start position and blah, 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 right? Which is true. And so this is the cool thing about TypeScript is it knows what's in here, right? It knows what's supposed to be in here, and then it sees that those don't line up because I'm adding these later. So what I can do is now just add those now instead. So add this in here, put that there. Then we'll have the start position, which is this thing minus this thing, and then that's it. Yeah, that's it. And now you can see, oh, the red squiggly went away because we have better types to match. And now we don't care about this because we've already done it. And then instead of pushing this message parse, which again, beauty of TypeScript is telling me, hey, this is not right. Parse logs is supposed to be parse logs, but here you're pushing message parts. Message parts is one of these things. These are not the same thing. So I can do the right thing. And we're all square. So now we've gone from just lying about what's going on here with these types to actually being exactly truthful. So here I'm saying, in order for me to get TypeScript to work in this case, I basically just say, hey, just you don't know what this is. I'm going to tell you. That's what this is doing. I'm telling TypeScript just to stop worrying about it. And then I tell it, now that you're not worrying about it, here's what I'm just going to tell you what this thing is. It's this, right? And we know this is true because it's easy to look at, right? We can look up here at this regex and we can see that this is actually correct. We still could have just as easily lied here. This is not actually technically tested. Still could be false. But now it's not knowingly false, which is a better position to be in. Okay, so we've got these logs now. And now I want to update this so that our tags, which currently don't exist anywhere. Oh, here we go. So here's the tag, which as you can see up here is optional, right? So let's make this not optional. And let's make it a string array. And so now we're going to get an error again because here, this thing is coming in as this thing called tag, right? It's right there. And it is optional. And so when we spread it, when we unpacked it into this thing, we just have a tag at best instead of a required tags that is a string array. So then what we can do here is we basically spread this thing in here, and then we can add tags and have that set to message parts. I got another good utility function here if I can remember what it's called. I always forget what it's called. It's called like, it's the ability to take a thing that you want to be in an array. That you want it to be an array, and it might already be. And so if it's not, you want to wrap it. That's what it was. So then you want to wrap it if it's not one. So we'll do that. So we can do a. Although here in this case, message parts is always going to be a string or nothing. So we're just going to do a ternary here and just say message parts dot tag. So message parts dot tag question mark. If so, then we'll wrap it in a array. Otherwise, we will return an empty array. And I'm pretty sure that my wrap function actually handles that also. Sorry, my alarm's going off. I'm pretty sure my wrap function also handles that, so we could just use that instead for funsies. Wrap if not array. Wrap if not array. There we go. Because this actually does the same deal, where if this value is undefined, it just returns an empty array too. So there we go. Just kind of shortcut that. And this is typed so that it actually tells you that. So then this will know that it's returning an array of strings, which could be an empty array. An empty array is also an array of strings, technically. Tardigrade, nice name. Is TypeScript a C#izated version of JavaScript? That is basically my understanding. I have actually never programmed with C#. It's one of those languages that if I had a reason to explore languages, it would be at the top of my list for languages to play with. I'm just so happy these days in my Node and TypeScript land that I've had no need to change. But yeah, my understanding is that C#, it's that flexibility of the type system that TypeScript has is something that is shared with something like C#. I don't think, to my knowledge, that C# lets you get away with as much as JavaScript does, because JavaScript doesn't require types, right? I think C# does. So with JavaScript, you can always at some point decide to do whatever the hell you want. You always have that option. And to tell TypeScript to just ignore what you're doing. You can always do that. So it allows for that progressive opting in of having TypeScript help you, opting into those features. I don't think you can do that with other languages, but I don't know. I haven't used C#. All right. So we did that. We got this thing of tags in here now, and so that makes more sense. So again, tags can now come from multiple sources with this new system. So they could come from here, up in the sort of the top end of our message, but they could also come from those pound symbols at the end, which we're going to parse out a little later. So, all right, so we've got this log here now, and then we add it to our array, but this thing isn't done, right? So we went through another step where we said, all right, we found the start and stop positions of these things, but we didn't actually find where they are. We didn't find their content. And so that happens next, where we populate all of that. But we also haven't parsed the rest of the stuff out, so we don't know which line is the sort of the first line. We don't know what the other tags are, if we want to have other features in here that we had talked about, such as, maybe let me put this in here. So any other features that we want, whatever those may be, then we would need to parse those out as well. So for the moment, that's really just basically the sort of, we'll call this the title and the body. So I'm not gonna keep the concept of a footer, because I like the idea of there being like a title line and then just other stuff, and the other stuff could have any number of paragraphs. Who cares? It's just whatever's in there. So we'll ignore the whole footer concept, and we'll allow for sort of what do we call it, like special, like keywords and special characters, I guess, to be used to indicate other functionality. And as much as possible, we should just let that appear anywhere. Like, who cares if it's in a footer or whatever? We should just let it appear wherever a user would want to put it. Minimize how much learning a user has to do. So that means all we want to do is be able to pull out the title and the body, and then to clean it up if we feel like we need to do that, and then to pull out tags. And then at that point, we actually have basically, actually, here's the remaining stuff. At that point, we have enough to move on to the next part. You can see I do have a few other items here where flagging a change as breaking, or flagging a change as closing an issue, which is a GitHub style thing, or referencing a user so that I can basically ping them when something gets pushed onto Git. John Flavin, welcome. Reminds you of type annotations of Python, which adds static type checking to another famously just do whatever non-type language. Yeah, presumably it's going to be the same kind of a deal. I'm not familiar at all with Pythonic type annotations. Are they all comment based, like with JSDoc and JavaScript, or is there a Python TypeScript equivalent that really do anything? I mean, I assume it depends. So the type annotations are comments, probably, right? So then whether or not they do anything will depend on your IDE, because you can do that in JavaScript / TypeScript too, right? They're not comments. Okay, so it actually is in the code. So I guess it's just TypeScript style to some extent. Yeah, I'm not familiar with it. I don't know. Python used to be my go-to language, but once I went to Node, and then especially TypeScript, I don't look back at all, especially for doing, since so much of web stuff is just managing data, and JavaScript is designed so that data structures, like in JSON or other formats, and data in the language are just the same damn thing, and so it makes transitioning really easy. So types are part of the language spec, they're just ignored at runtime. Gotcha, okay. So yeah, so types in TypeScript are not only ignored at runtime, but don't exist because they just get stripped out of the JavaScript, right? So that must be similar then. But it's not built into the language, which is a bummer. So you basically, because it's not built into the language for TypeScript, you have to use some other tool to basically strip that out before you go into runtime, which then adds all this tooling overhead. So some of the newer stuff like Dino and probably eventually Node, and hopefully eventually browsers are starting to support TypeScript natively, so that, which in the end again is just stripping out all the type information and running the raw JavaScript. But right now we have to do a bunch of overhead, and that part kind of sucks. All right, so we got this thing. We're going to add, just so we've accomplished something. I'll overwrite a little code, and we've talked about some cool stuff. But we want to wrap this up with parsing out that last piece. So let's yank out the title line, and then the body, and we can do just a tiny bit of cleanup on those. What time is it? Just past 9. Ooh, it's closing in on bedtime. So yeah, we'll just kind of try to wrap that up real quick. All right, so here we grabbed everything originally to find where everything was, because we only know where one body is by seeing where the next comment starts. So we had to do that first, so we could find out all those sort of demarcations, and then once we did that, we can loop over all the stuff that we found, and then use those start and end positions to pull out the bodies in between. So we tested that worked. That's what showed us. I'm not logging that anymore, I guess. Okay, back when we were logging that, then we saw all of that. So now in this loop, we end up with it. So by the end of this loop, or end of each turn of this loop, we've now added the content, which is just the raw string, to this log. So what we can do is any other parsing cleanup we want to do. So let's identify the title, line, and body, and then remove extraneous new lines, because we can. So single new lines in Git messages are basically ignored, right? When you're writing a Git commit, your editor will probably, if you're using like Vim or V or maybe even Nano, I think Nano doesn't care as much, but if you're using a lot of things, they're going to give you a break, a line break at like 80 characters or whatever. I mean, you could set all of that stuff, but the default is something like that. So that it's trying to make it so that your lines aren't very long, so that things don't have to word wrap. Given the modern tools that you're normally using for stuff, I don't really see any benefits to that whatsoever. Why not just word wrap and let people choose if they want to have things with new lines? But the main point here, though, is that new lines make parsing hard, because you have to add, there's a layer of interpretation that gets added, and because usually you're parsing with regexes, and with regexes, new lines have special features and behaviors, and you have to know how to set the right flags and do all this stuff properly to make sure you're handling that. And so if we could just, not handle that, that would be ideal. So the idea here is that a single new line, anytime you have a double new line, that's meaningful. That means there's a blank line. Anytime we have a single new line, we do not care. It doesn't mean anything. We can just replace it with a space. And now everything's on one line and easier to parse. So that is what we will do. Actually, we'll just do that first. We'll do that first because we can basically replace every instance of a new line that isn't preceded by another new line with a space, right? And we can do that with what is called a negative look behind regex. So we'll do that first. That way we'll clean up our message so that all extraneous new lines are gone. And then what's left, we can just split with a new line split. Easy peasy. So let's do that. Let's make a regex here, which is, we don't need to make it in the loop because technically that's more costly, but also who cares? Now we're keeping it in scope, so we don't think we should be using it outside of the scope. There's no real performance cost here. We have infinite compute power at our fingertips. So what we're gonna do here is we're gonna make a regex called what is this thing? This would be regex extraneous. Wait, where did I use this word before? It just knew this word. Oh, I just did it right there. Extraneous new line regex is going to be equal to. Okay, I always forget the negative look behind syntax. Anybody remember it offhand? Can anybody do it? Can anybody remember it? So it uses a group. It uses a group, and then it's going to be some combination of a question mark, because that's how usually these things are prefixed. And I want to say that. I think that's negative look behind. Let's see if that's true. Anybody remember offhand? Regex negative look behind. If anyone would be interested in just having a
a stream about regexes. I love regexes. They're one of my favorite things in the universe. We could do that. I don't know what we would do exactly besides play with them, you know, just like try out some weird data fixing problems or something. All right, here we go. Negative look behind. Yeah, because the pound is usually not, right? So that's your negative part. So check us out the look behind can be matched here. Matches a B that is not preceded by an A. Yeah. So it looks like I did it. Looks like I got it. I assume a look ahead. What does look ahead look like? So it looks like a look ahead just doesn't have the less than sign. John Flavin, you got it. That's correct. So it's this thing. And so now what we're going to look for is we want to not find. So basically, this is the parens here, demarcator groups. This is the thing we're basically not matching, or matching the opposite of, sort of. It's not quite right, but that's kind of the gist. So what we want to do here is we want to not match a new line, then match a new line, right? That's it, actually. So what this means with a negative look behind regex is that we're matching a new line that is not preceded with another new line. It could be preceded by nothing. This could be the start of a string. It could be preceded by literally anything else, and that's fine. It just can't be preceded by a new line. So we're going to look for that, and then we are also going to, I don't think we need any flags here, but we'll find out if that's wrong. So we're going to have that thing, and then all we have to do here now is we'll overwrite our content, because we're just going to replace it. So this will now make our start and end positions wrong, but the only reason we got those was to pull this thing out, and so we don't care at this point. So a reasonable thing we could do here would be to then delete those fields so that we don't misinterpret them later. But the end result of this is going to be, I'm going to make a new class at some point once we get this all parsed. I'm going to make a log class that basically takes all this crap as input, and it'll just ignore that stuff anyway, and then we can use that class to do all kinds of weird fun stuff. So we can not worry about it for now. But it is putting ourselves in slightly dangerous territory, because then if we're doing autocompletes and stuff, we'll be like, oh, what is this start position? And then we'll try to use it, and it'll just be wrong. Well, you know, it's life. Sometimes you're just wrong. All right, LG, so we're going to replace it with itself. Where we're first going to do is we're going to do a replace, and we're going to do a replace where we're going to remove all carriage returns /r's, because we don't know where this is coming from. Most people are using Windows probably, and so if they're using Windows, then those things are going to have those dang /r's in them, which are just the worst. So just pull all of those out of there. Just get rid of it. Global to kill all of them. Just replace it with nothing. Yeah, just kill those dang /r's. Let's see here. So who's got some stuff in the chat? I'll look over here so you're not looking at the top of my bald ass head. So it looks like, yeah, it looks like Twitch does not like those characters in the chat or something. So not sure what happened there. Yeah, may have been protected against SQL injection, though. Anytime you see something where somebody prevents the characters that they're trying to, make not go into a MySQL database, then that's actually an indicator that they have a worse problem, which is that they're not cleaning up their strings, because there's nothing wrong with those things. You can put all those seemingly dangerous characters into a database just fine, as long as you escape them first, which should be happening on every single thing that goes into a database in the first place. I know this because the original version of Bscotch ID from a million years ago, before I knew anything, strictly limited what characters you could put in your password, which is really annoying for everybody. And then I learned a while later that that was a thing I didn't have to do. So anytime you see that, you should be annoyed. So it showed up in the chat, but not the overlay. Oh, actually, no, I bet I know what that is. Probably because the overlay is actually going through a little HTML widget that I can change the CSS on and stuff. And so probably, since it's coming in basically as raw text, then those characters are being treated the way that you would treat characters in HTML. And so if any of those look like things that need to be HTML escaped,
then that would also do that. I'm not sure why exactly these specific ones would though, because those should all actually be fine. Yeah, they may have a, in that the JavaScript they're using for that, which I actually don't have access to, I can't see it. They may be doing some sort of escaping or stripping of stuff that looks dangerous. That's also possible. Omnicar asks, so extraneous newline regex is meant to match singular newlines. Yes, correct. Newlines with no buddies. Nobody newlines. All right, so we're gonna do some fun chaining here. So we're gonna take content, we're gonna replace, we're gonna get a new string. So basically, replace returns a new string. So we're gonna replace all instances of a carriage return with nothing. So we just get rid of those because those cause confusion and chaos. And then we'll do another chain on here where we're now going to replace extraneous new lines with also nothing. Yeah, that's what we're doing. Then in principle, we're done now, supposedly. Does anybody believe it? I don't know if I believe it. Although now we can actually just see what happens if we just go back and log this again, so we can see the output here. Console.log parsed. Yep. Yeah, I can just see what that looks like. Test. Omnicar testing on regex 101, and it seems to match any new line. Should we check for other new lines before and after? It's matching when it shouldn't. Let's find out. Let's see what it's doing. Let's see what it's doing. So, oops, I want to extra place with the space. So it looks like it's behaving as intended. Except we need to replace it with a space. It looks like it's working. If you're using that website, regex 101, does that take into account carriage returns? Although I guess that wouldn't be your problem because you're finding it's replacing more things than it's supposed to. You can go from just like the top here, take a look what this is doing. Ooh, no, I see what you're saying. Yeah, right. It's actually because, right. It's because the first new line of any pair of new lines will not have a new line before it, so that also gets replaced. Yeah, you're right. Crap. That's right. Okay, there's a dumb way to do this, but I'll try to avoid doing it the dumb way. It'll work perfectly fine. What's the way to do this? Is okay, so what's the case? We want to have a new line that doesn't have a new line on either side of it. Yeah, so we do a negative look behind and a negative look ahead. Right? Yeah, that's what we want to do. Okay, so we'll just put a negative look ahead on this side, which I guess must look like, because I think it's the same just without the less than sign. I think. Let's try that. Right, a new line with no new line buddies, not one in front of it. Start at the top. There we go. Yeah, good catch, Omnicar. Yeah, the look aheads, look behinds, and the negative versions of those are not supported by every flavor of regex. So it depends on many things, and I think until recently weren't supported in JavaScript either. So JavaScript with the ES6 update from 2016, whatever that was, that's when it got all the fun, cool stuff, all the good bells and whistles. That's when it got your named capture groups, which it didn't have before that. I think that's also where it got look aheads and behinds. But yeah, so now you can see, if we go compare what this is supposed to look like. So here we can say, all right, so this had a double new line, as expected. And then the next line here, oh, wait a second, what's going on here? Did something, wait. That wasn't at the top, there we go. And so then this line here had a new line breaking it up after this period, which is now gone. It's now gone. And if we keep on going down the list, we should get the same sort of outcome. So it looks the same. And then here we've got this one, this line,
which says built something, whatever, and then there's blah, 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 and that does that. Does that too, so it looks like this did it. Yeah, it looks like this did it, except for down here. Except for down here. Why did that one not work? Is it because I forgot the global? It's only doing it for the first line. Sean's Flavin says, seems like /n and then look. Oh wait, yeah, and then capture group extraneous /n star would be simpler. So that would be if I'm going to match a new line followed by any number of new lines. So that would be matching, including 0. So that would be matching one or more new lines. Unless, right? Isn't that what that would do? There we go. Now it's working like a charm. Beautiful. This is just exactly makes the heart soar, you know. Then replace the extraneous group. This is extraneous. So, but that's going to match any number of new lines. Or I see. So extraneous then would be, because we want the other way around, because that'll be replacing things that have a new line. It'll be replacing the other new lines. So if there are new lines back to back, it'll replace the ones after it. But we want to take the ones that are just by themselves and don't have any back to back. Let's see. You have 2 new lines in a row in your example. Do you want people to put an empty line between messages? I don't want to force that because it's easy for me to tell with a regex that both of these lines follow the pattern meant for a new message. And so if somebody messes up and forgets an extra new line, then I don't care. Why should I can detect that? So I'm not going to put that on the user. So that's kind of how I try to think about things. Is if it's fairly unambiguous what an intent is, then I have the robot do the work instead of having the person do the work. If that makes sense. So in this case, if I were to write like a strict documentation explaining how this works, I would say that there should be new lines, there should be a blank line in between any like pair of messages or whatever. What I would still do with the code in practice is try to identify the likely error points that somebody would make, and if their intent is unambiguous, just fix it. And this is particularly useful for something like git commits, right? Because a git commit is meant to be an unchanging thing. And yes, you can rewrite a commit. You can do a rebase, or you can do a git commit amend. You can definitely do that kind of stuff, but that's the kind of thing that you have to know what you're doing and why. Otherwise, you can run into problems. You can create problems for your compatriots who are helping you work on stuff. So we wouldn't want to force somebody to have to rewrite a git commit in order for the parser to work, right? For cases where that doesn't matter as much, then yeah, you could put more work on the user if you wanted to. But I try to avoid doing that wherever I can. Yeah, this is just one of those cases, and they're not often enough where I can see a mistake and it's unambiguous that it's a mistake, and the solution is also unambiguous. It's the best kind of mistake. Yeah, this all works. Cool. So now we have this aspect of the parser where we're cleaning that up, which means we're going to have this final step now where we can take the title line and the rest of the body, and we can break that apart too. Though at this point, actually, now this is all cleaned up, this is probably the right point to now make a log class that will take this chunk of data, this data structure that we made, as an input, and then let us do all kinds of fun stuff with it afterwards. So instead of just mutating the data on the fly in this sort of plain vanilla object, if we can do it as a class instance, that'll give us a lot more flexibility and a lot more ways to expand functionality instead of just have this sort of hard-coded structure. So I think that's what we'll do, is we'll just have this thing cleaned up, and then down here, like I said, we can do up here, we'll just go ahead and we'll make it, and this will be kind of the end of the stream. So it's ready to go for next time. Where we'll just call this this is a patch note, is really what it is, but we'll call it yeah, should we call it patch note? That is what it is. Yeah, that's what we're gonna do. We're gonna call it that. It's also, you know, in line with the whole point of this thing, this whole project. So we'll make a constructor. This thing is going to take a parse log as its input. So this is parse log. It's then going to do some stuff. So what I'll do here is, yeah, we'll just store this internally for the moment, and then we'll decide what we want to do with it in the next stream. But this will allow us to do something, just as a quick example of saying, like, okay, let's have a getter on this thing that gives me the title line. If for some reason I care about that, then I can take this .parseLog .content.split, and we can split it. Content does exist though. So we actually want all these things. Actually, let's do this. Let's make this thing required because we want to have that. Let's make this thing is optional, so that's fine. And now let's go change this thing. What did I say? Yeah, it was the content. So at this point, we don't know what the content is yet, which is why I had originally flagged it as optional, but let's just set it to nothing. Just set it to an empty string, because then it gets overwritten down here anyway. So that's fine. Makes our type a little easier to use and more portable, without having to do anywhere. Because we could change this type up here to then require that field, but you know, why? It's easier to read if we do it this way. So you can just do something like, okay, let's split this thing on a new line, and return the 0 with value. And now all of a sudden we have a title, which I should return. Duh. So then if we were to wrap this thing up with return parse logs dot map log patch new patch note log. Hey kitty, let's get off of here, huh, buddy? Yeah, no. Such a hard life for these kitties, huh? Alright, so we'll return that thing, and then we can just log it so you can see it. Yeah, let's do this. Let's do so a sort of a hidden trick of JavaScript is that there's a built-in function in both Node and in browsers called JSON.stringify and also JSON.parse. It does the opposite. So stringify takes an object, turns it into JSON. Parse takes a string, JSON string, and turns it into a JavaScript data structure. So when you call those functions, if you call them on a class instance, a JavaScript class instance, then it'll first check to see if there's a function called toJSON with this capitalization. And if there is one, then it uses that as the basis. Otherwise, it'll just return whatever properties you have that are public, which actually excludes things like getters. So that kind of sucks. So out of habit now, anytime I make a class of some sort, I nearly always add a toJSON function to return some basically shallow vanilla object clone of this instance, with the idea being that I can then use this to get a plain object to mutate and do other stuff with without touching the original class instance, and that when I write the thing to JSON, that will just automatically show up the way that I want. So I'll put that in there, and then we should be able to log this thing, we can call it a night. So if you got any other questions or any things you wanted to hit based on what we talked about today, think about them. Let me know what you got. Let's see how this looks. Taking its sweet time. All right, so now here's all of our patch note objects. Right? So there's no, so I guess it's not that there's no such thing as a private method or property in a JavaScript class instance. There actually is a native way to do that. It's using this #. So if you my private var, whatever. So if you use this syntax, then this actually is treated as a real private variable, and therefore, so since it's treated as private, then it won't show up if you console log it or do other stuff. But private as a keyword is used by TypeScript, but stripped out because it doesn't actually live in JavaScript yet. I think it's part of some of the new proposed specifications, but it doesn't exist yet. So this thing gets yanked out, which means parse log is just a variable on an object, on basically a plain object in reality. So when we're coding up in TypeScript, if we're trying to access this parse log property, then TypeScript will throw an error and tell us we can't do it. But JavaScript still can do it because it's actually not private at all, right? And that's why you're seeing it show up here, right? Because it's not actually private. If I were to instead change it to an actually private one with that pound prefix, then it wouldn't show up here either. But anyway, it does, so there it is. And now we can see what's in there. So we see our content, but what I wanted to do is see this title. So let's JSON.stringify it, and that way we can see that in action also. So it's console log JSON.stringify this thing with a... so this is your common pattern to prettify it a little bit. Which is, so this is a replacer function you can use to change how it stringifies things, and then this is the spacing. So if you pass a null in for that second one, then it just uses the default replacer. But the replacer is that thing that's calling that toJSON function on every class. There we go. So look at that. Look at that. Amazing. So this is pulling off the title off of all these dang things, which hopefully is correct. It's probably right. Yeah, that's right. It's doing what it's supposed to. Fix some stuff. Yeah, so this body's not in there because it doesn't need to be. We just rip the title off and pass that back. And so this would be the idea for the next steps, would be to now update this patch note class so that we can pull off whatever we want, whenever we want, but basically it just stores some raw data, and then we can use the methods, getters, and setters on the class instance to get whatever it is that we want, to change the behavior of this thing, and so on and so forth, so we can use it for other stuff. But this is, so yeah, so we could add another function here called body that instead of returning just the raw body, returns it without the header. We could have another function or another class method that returns the tags that are on there, basically fetches all the tags out. And there's probably actually a little bit of additional parsing we want to do in the constructor, but that's stuff for next time. So I'll make some notes here about next time. See, John Flavin says, how does this get packaged, deployed, run? Where does it run? So I would be, so you can just run it directly because the JavaScript is in here in this build folder, right? So if I wanted to, I guess there's nothing to run directly right now because there's just some stuff you can import. So if you wanted to use this, you could just in some other node project somewhere, just import it. So you can import that code, and then so you could, for example, import this patch note class, and now you have it. You could import this get message class, and now you have it. So you could then just use it the same way that it's being used here, where it's just being imported and used. So with a raw JavaScript, you could just do that, which means you could take the GitHub repo, you could run a build, and then you just have it now. For more convenient use, though, we would be packaging it up for deployment via npm and hosting it on an npmjs.com, which is, here we go, npmjs.com. So this is where you do, so npm comes with Node. It's just an executable that comes along for the ride when you do an install of Node. And and it's a local package manager that by default talks to this repository that lives here. But you can have a custom repository that you host yourself. GitHub has its own repository for Node packages. And basically what this thing does is you can provide some instructions in the package.json for which files to include in the bundled deployable thing, and which things to exclude, and then there's basically just a publish script that you run that will do whatever it is you tell it to do. So in this case, we would build all of our stuff, maybe run tests, all that kind of stuff, and then it'll finish with basically putting that into a tarball and uploading that to NPM, and it'll do that using whatever name we've provided here. So in our case, we have an organization on NPM called @Bscotch, and so that's where our official stuff goes. If you were to do this with your own stuff, then it would just show up, just like it would just be called patchnotes. Unless you can set up an organization as just a namespace, so you can just do it. Sorry, I have to knock a cat off the table. She's eating cords. Yeah, and so then once that's there, then somebody just now on their own machine can just run an npm install, and then in this case it would be bscotch/patchnotes, and now they just have it. So this one isn't published yet because it's not doing anything worth publishing, but the other stuff that you can do along with that we'll talk about once we get there is you can add some stuff to your package.json to flag files as being executable so that they can now be used as CLI tools, which is also part of what we'll be doing later. And so now what it allows somebody to do is they can just do an npm install, they can install some package that'll then ship with a whole bunch of executables. So now people have a bunch of command line tools they can use, as well as the code that then people can import to build code-based pipelines or do whatever they want. And you can see that with Mocha, actually. Mocha's a good example of this. Is Mocha now, so if I run Mocha directly, I didn't install it globally, so it's only available here, which you use npx to do that. But so Mocha, when I did an npm install of Mocha, that went into my node modules, pulled all these files down from Mocha, right? Whatever this stuff is, Mocha right there. Pulled all this stuff in here, right? And but then it also added to this .bin folder up at the top here all of these other things. So it's like this underscore Mocha is a binary file. There's also one just called Mocha that I think just maps onto it probably. Mocha, yep, right there. And so that's what makes Mocha now just runnable from the command line. It seems that my cat has, I don't know what she was doing back there, but she did something. Suddenly everything froze, everything went to hell, had to reboot the computer, you know, the whole deal. It's also possible that that was a coincidence and the streaming broke something because it takes a lot of juice. I think I kind of hit the answer to those questions there, which is basically how these packages get, where you can make CLI tools and stuff. Oh yeah, and what I was about to show was our other projects. So you can see this in action. If you were to go look at, let's look at Bscotch/Stitch. So this is a tool for doing pipeline development with GameMaker Studio. Files, these are things that get packaged up when I do an npm publish. These things get packaged up by npm, the local command line tool, and they get published to npmjs.com, or you can change that with some settings so that it goes to a private repository or to GitHub or to something else. And then this bin section is for setting up binaries, for setting up command line mappings, so that I can in here say I have a binary called Stitch, and I point it to my JavaScript file, and then Node does the work. So Node will do the work of saying, okay, I'm going to make this thing executable, and then make it available on your path so you can run it, and so on and so forth. So we'll be doing the same thing with our tool. Omnicar asks, does it get to the commit messages straight from a repo? I assume you're referring to this project that we're working on now. Is that correct? In that, the answer there would be yes. So what we would be doing with this tool, with this patchnotes tool, is we would be making it so that you would install it, and you would now have the command line tools available, so that you could run a command called like patchnotes build or whatever, right? And you could either do that from within folder where our Git repo is, or you could point it at a Git repo, or maybe you can point it at a GitHub repository, and it could do it using stuff on the internet. And then it would do all the work for you. So you'd still have to get it there. You'd still have to get it or point it to the right place, but then it would just look at the Git repo and pull it up. Toxa asks, what's going on here? It's a good question. What's going on anywhere? You know? This was a stream that was about to be over, and then my computer froze and or my cat destroyed something, and now it's still about to be over, just wrapping it up. So it's part 2 of the stream. We're basically talking about how to build some cool Node.js tools, in this case specifically for making automated patch notes for, in our case, our video games, but it could be used for other kinds of software too. So that's all the other questions that I have seen. So now we can commit the stuff and push it, and then again, if anybody has questions while I'm doing that, throw them in the chat, and then we will wrap this up, hopefully without any additional disasters. What changes we made here? We installed some stuff. We added to test things, added source map support, so that happened. We updated our ESLint rules, and we added a custom errors and an assert. And we did all this stuff as well. Like, we just did so many things. This is actually a perfect example for us to do a multi change commit, which is supposedly against the rules and things like conventional changelog don't handle, and just part of the reason for this whole thing in the first place. So let's do all the things we did. So we did a chore here where we added source map support. Actually, let's call this test. Add source map support to tests. What else did we do? We also did tests, and then we did a feature where we did something. We did a feature where we added a parser, where we cleaned up the content, and we made a patch note class. Feat, clean up parsed message, I guess log bodies, and use them to instantiate a new patch note class. That's the thing we did. What else did we do? We also added a custom error. Feat, add a custom error to help differentiate our errors from internal ones. Is that everything? Is that it? More or less close enough? Yeah, it's close enough. All right, so now we got a bunch of things in here, and so we can say when this commit message here, that's got 3 sort of patch notes in it, right? When this shows up in most contexts that are managed by Git, you'll only see the first line, or that's the main thing you see. If you're looking on GitHub, you'll only see the first line. So then we can choose which one of these we want to put first. That's the most useful. And then the rest we know in the future someday, once we have this whole patch notes thing working, will show up in our changelog at least. And it's of course still available in your Git log. You can still search it. You can still do all that kind of stuff. It just isn't sort of front and center. So the one that matters most here is going to be that one probably, because actually no, it's going to be this one. This is the most directly useful for what we're actually working on. Okay, so then we can do a commit. So I'll paste that in there. That's all the stuff we want. You can see it broke these things like I said it would, because this is Vim and it doesn't like word wrapping. It's not into it. Make sure nothing weird happened there. Git log, there we go. Yeah, so you can see here if we do a regular git log, you can see all those things, and we're doing great. If you're to do a git log one line, which I think just goes like, I think it's just like this. Is that what that is? One line. Yeah. Then now you can see we only see the title lines, right? Which again is what you see in GitHub and stuff. Let's see here. GitHub, yeah. So So we used to be on Bitbucket and switched over to GitHub because that's where everybody else is. And the tooling there is really good. I've been playing with GitHub Actions lately, which is for doing automations on your repository, on your code, so that when you push something, you can cause things to happen, you can cause tests to run, whatever. In our case, I'm playing with it for our internal feedback system for our QA, so that when our QA members leave reports, then we can have robots do things like parse that report and automatically add the right tags and assign it to the right people and all that kind of stuff. It's very neat. Yep, thanks Omnicar for describing what Git is and GitHub. Yeah, people confuse Git and GitHub pretty frequently because, they sound like the same, and GitHub feels like the official thing for Git, but that's actually not true. Git really is a separate thing. It's just that GitHub is so popular as a tool that it's where everybody's at. So they sort of have become synonymous. That's another potential stream we could do too. We could talk about GitHub Actions or something. They're very cool. All right, so we made our commits. We can push this, which then ends the stream unless I see any other questions in the last minute. We should now see these available. We should now see this last commit when we get back to patch notes. Oops, let's go back here. How did that happen? How did that happen? GitHub.com/Bscotch. Not Stitch. That's not what I want. I want the patch notes. There we go. All right, 3 minutes ago was the most recent commits. So we have everything here that we should have. I should probably be adding to our to-do list in here so we can keep track of what's going on, but whatever, it is what it is. All right, so that is the project for today. So that was part 3. Parts 1 and 2 are up on what do you call it? YouTube, that thing. It's up on YouTube. So those go into a lot of detail, part 1 in particular, on the whole setup process for a project like this in the first place. We're now finally, as of the last 2/3 of part 2, and then now this one in part 3, I'm getting into some of the code, though of course we're going off and doing other stuff at the same time. So this will be continued. The next step will be finishing up that early parsing step that we've already started, and then getting into Git stuff, where we'll be asking, how do we now that we can parse a Git message, how do we get the Git logs so that we can have messages to parse in the first place? And then from there, how do we now start to construct patch notes by finding versions of things and putting all that stuff together? So if you are subscribed on Twitch, then you'll get pings, presumably, the next time that this thing goes live. If you go to our YouTube, you'll also get pinged when those go live. So you can find this both ways. I also announce stuff on my Twitter at CosterAd, so you might see those there. And then also, finally, in the Bscotch Discord, there is a role you can go click on that will make it so that I can ping you when me or Seth or somebody else is going to go live doing some dev stuff of some sort. So if you're into it, there's a whole bunch of ways you can find it. Thanks for hanging out. Thanks for watching, everybody, and glad you're here to hang out and do nerdy stuff with me. And hope everybody just has an excellent day. What is this, Wednesday? Excellent Wednesday and rest of your week.